It got to me out because they won't respond.
So if you feel like
Willie, come on.
feel like something's wrong with it entirely, just
Oh, well, it got me saying that. All right. Don't laugh.
I'll do much weirder things than that. Hey, sorry, it's a little bit after 12 because, you know, I'm a stickler about starting right at 12 o'clock. You guys know I am. Welcome to my club. Who are my new people with me? Could you raise your hands? Do you mind? Just so I can look at your faces. Okay. So you guys that were new, you got a little name thing, and I'll try to be able to learn your names actually maybe this week, hopefully. Did everybody sign the roll? So you sign this. We'll get rid of this business stuff first. I just saw Brittany. Where is she? Okay. Great. And you've gotten a syllabus, right? Everybody's got a syllabus? Okay. So this is microbiology, introductory microbiology, and this is my favorite class here at the community college, so it has to be yours. No pressure, right? No pressure. But anyway, I hope you're going to love this course. I just can't imagine why people wouldn't, because we definitely live in a microbial world. I know we think it's all about us, but 80% of the life on this planet are microbes, and we couldn't live without them. They're allowing us to be here. So I really do, I do like this course. I teach it very differently from my A&P course. So for those of you who have never had me, that might be better for you guys. But for my A&P people, it's a whole different ballgame. Okay, so just giving y'all a little bit of a heads up about that. I don't really approach this course the same way I do for A&P 1 and 2. How many in here have not had A&P 1 or 2 or not currently in it? Is anybody in here never had A&P 1 or 2? That's fine. And you don't, it's not a prerequisite. It's really not a prerequisite, but I do think that most students would find that it helped them, that they had, but you do not have to have had it. I'm just giving, I'm just letting you know that. So we're all different anyway. We all come at things from a different viewpoint, so I say something and I'll have this many different interpretations of what I said, right? And that's just the beauty of life. So don't worry about that, but I do think that for some of you, you'll think, okay, well, I'm glad I had A&P. But anyway, it's fine. So it'll be okay, I promise. This syllabus is a contract for the course. So I'm not going to read it to you because I know that you can read it. Y'all know that you have Canvas that's going to allow you to be able to go back and look at these lecture recordings if you want to. You don't have to, and sometimes the technology won't even allow us to, but hopefully it will usually allow me to go ahead and post up these lecture recordings. So if you wanted to, you could go back and listen to the lecture recording, or if you missed a class, you could listen to the lecture recording, because I do expect people to be prepared every day that they come in here. And what I mean by that are these lecture quizzes that y'all are used to me doing. What we will do in here is every day that we come in after today, we will have a lecture quiz. So we do have the lecture quiz on just what we talked about the last lecture. So if you're taking good notes, you don't have to re-listen to the lecture recording. Or if you've got friends in the class that you can just compare notes with, then certainly that would be fine too, right? In this class, your textbook is really mostly just a reference for you, a reference book for you, and you do not need anything for the lab. So you're not going to have to purchase something separately for the lab. I am going to lecture on our topics, and sometimes those topics I will kind of stray away from maybe even what was on the PowerPoint. I wouldn't really do that, would I? Sometimes I've been known to do that, but what's important is what we talked about. Is that right? So you will only in this class ever be tested, ever, on what we talked about. There will never be a quiz question or a test question on something that we did not discuss. So if you're doing your part by being here you're doing your part by taking notes and just trying to be thorough, then you should be fine in this class. Is that fair enough? Fair enough. Okay, in lab is very kind of different from, again, also the A and P 1 and 2 labs. In the labs, we will be doing things that should kind of be going along with what we're talking about, but it won't be exactly the way it is in A and P, where you are looking at hearts and you're in the cardiovascular system, right? And it's just the nature of the beast for how this is, but it certainly supports, lab supports what we're doing in lecture, but your lab quizzes will be just on what we did in lab. I will never quiz you on something we did in lab. I won't bring it over to the quizzes or tests in this class, in the lecture. Fair? Is that fair? Again, you will never be tested on something that we did not discuss. Now, is there anything, I know I just gave you a hard copy of this, but maybe you all looked at your Canvas. Everybody able to get to Canvas? No problems with that? Okay. I know you're just kind of looking at this. There's a presentation that you will do in this class, and I'm going to give you out the rubric for that on Wednesday during class and go over it a little bit more with you all. They won't be due until the latter part of this semester, like the last couple of times we meet. You guys will be doing this. These are just like 5 to 10 minute presentations on some of your case files that are found in the textbook, and they will be assigned. So different ones will be assigned, and so you guys will do that. You do not have to stand up to do it or whatever. It's not as formalish, so don't get nervous about that if you don't like presenting in a class. By that time, we'll all be really good friends. I hope. Some of us already are, right? Again, in this class, it's a little bit different from A&P because A&P 1 and 2, I have so much material that I'm having to cover. I feel like it's this real lecture thing that's going on, but in this class, I'm going to, at the beginning of class, I'm going to try to have things that I'm just hearing about in the news that I think you guys might be interested in that are pertaining to microbiology. And if you see something, then I want you to bring it in and just share it, either discuss it yourself or open it for discussion. This is more, I treat this class a little bit more like almost a graduate level class, in that we have more of that kind of give and take time that we actually have for this. There are some things I do have to cover though. So sometimes I will be pulling it back and making sure I'm covering what we need to be covering, okay? Do you have any questions for me? Take a look before you sign your contract. I'll give you some time at the end of class today. You don't necessarily have to do it now if you haven't looked at it yet. But the last page you'll turn in today if you agree with this class, what's required of this class. Okay, so take a look at how the grading scale is, where the grades come from, and just what we are planning to do in this class. And hopefully you will think, okay, I'm staying in the class, and you will turn in your signed contract before you leave. This will be your attendance for today. I'm going to give you credit for doing these contracts. I'll do that too in AMP too that we just had. So I give you credit for attendance by saying that you turned in your contract today. And after today, you'll always have that little quizzes that are going to be happening, right? And or tests that will happen. Quizzes are going to be filling in the blank, those types of things. Tests are all multiple choice.
Can
Yes.
you use a book as much as we were in?
No.
We can use our book for it.
Well, it's a reference. So I've taken a lot of the slides from your textbook, so it is a great reference, especially for spelling, because I'm not going to stand up there and spell. So it's a great reference, and then you also, that case presentation y'all have counts as a test. So that's coming from the textbooks, and that textbook is great for that. I will say this about this textbook. It's probably one of the better microbiology textbooks I have seen because it gives you those NCLEX questions, those practice NCLEX questions, which are kind of cool to be seeing and reading, and you need to be doing as much of that as possible before you go into any kind of clinical program, because there's always that certain way that they write those questions, and your brain gets used to seeing questions that are written like that. Is there anybody in here that is not going into a health science field? Okay, so you're not, what are you going to be doing? Do you know yet?
Not quite. I'm thinking wildlife biologist.
Okay, well, that's awesome. Okay, well, so you're going into the sciences. So, and like I said, 80% of the life on the planet is microbial, and all that wildlife that they're relying on the microbes as well. So, so great. That's fine. Sorry to call you out. You're good? Okay. All right. So guys, that's just, I'll let you all have a little bit of time at the end of class. And like I said, I'm not going to read this to you. I know you can read and figure out. And if you decide to turn in the contract and stay in class, then that will be great. I do think in a lot of ways, people are nervous about how many of you have heard just horror stories about microbiology? Only one person's heard. Okay, so I've had a couple of people who've heard that this is just a terrible, terrible class because you're learning about all these different microorganisms' names, and you have to know the diseases they cause, and that's really true. And guess what? This class is no different, and you really will be doing that. What I would recommend, and I'll give you guys this as a big hint right now, is when I introduce the name of a microorganism, and I give you maybe the genus and the species, write it down. And if I tell you where it belongs, which kingdom or domain it belongs to, write that down. And if I tell you a particular disease that it causes, write that down. And then when you're studying your notes, start either your colored index cards or start your chart, and make sure that once I start introducing these things, those are fair game for me to ask you at any time, even if I meet you in the hallway. Okay, I would not do that. But you need to know them as we go. Your final exam in this class, I'll give you a little heads up about this final exam in this class. The final exam is exclusively what I just said. I'll be asking you for strep throat. This is just an example. Strep throat is caused by which microorganism? And you'd have to say Streptococcus pyogenes, not Streptococcus agalactiae or pneumoniae or faecalis or faecium, not those. Streptococcus pyogenes. You need to know the genus and the species. But will that be a very fair question? Yes, it will, because I will have talked about it. Students get intimidated in microbiology because of these genus and species names. And they feel like, oh, I will never have time to memorize all those names. Do I want you memorizing those names? No. I will be introducing them just some at a time, but every time I introduce one, you need to learn it. And so it won't seem overwhelming to you that when we get to the end of this semester, that we had a significant list by that time, and you know them, because by that time they're going to seem like your friends, right? Or at least those crazy relatives that you know, right? So they'll seem very familiar to you at that time, as long as you've been doing your part and reviewing them. I will never ask you about one that I haven't talked to you about. Good? If I do, what will you tell me, Casey? Casey, you are not on your phone, honey, right? Okay. Okay, I know what you're doing in your lab. No electronic devices are allowed in the class. So, okay. Sorry, Casey, I just thought it looked like one of those lab text things. Anyway, I forgot the question I asked you now. What did I ask you? You don't know either. What did I forgot?
You said, what would you ask? What would you say? You asked a question that we have not reviewed.
Thank you, Jay. He listens to me. So if I ask you a question on a test or a quiz that I haven't talked to you about, y'all will tell me, won't you? And I will throw the question out. Is everybody feeling really relaxed now about this? Are you? Okay. So why are we in here? A lot of people say I'm in here because I need a science lab. And I need so many science lab courses before I can go on to Virginia Tech and get my, whatever, or wherever you might be going. Can you tell us where you're planning to go?
I do not know.
Okay, well, good for you. You have lots of time to decide. You might end up changing and going into health sciences after this. But anyway, so people say, why do I need this? Why do I have to take something like this? Well, honestly, it is true that some classes are obviously required for that content, right? But this class is, it's unbelievable to me that people doing any kind of health science, I don't care if it's PT, OT, nursing, whatever, that this wouldn't be a required class. Because guess what those people are? They're on the front lines being exposed to infectious diseases. And when I say infectious disease, I would want you all to understand that that's going to be a disease-causing agent that can be transferred to other people that come in contact with that person, right? So an infectious disease is something that can be passed to someone else. It can be caught, if you will. In modern times, in our country, we are so very lucky. And it is so very different right now than it was even 60 years ago. And some of y'all are thinking 60 years ago. But it is so very, very different. Because let me say this to you guys, and this isn't like in every country, but just in our country, because of the advent of antibiotics that work against bacteria, antivirals that work against viruses, antiprotozoals that work against exactly, y'all playing the game good. Antifungals that work against fungi, right? With the advent of all of those chemicals, chemotherapeutic agents, a chemotherapy is the chemical that will treat. So those are all chemotherapeutic agents, aren't they? Without those and without immunizations, people had about a 50-50 chance of making it to their 5th birthday. That means that my mother's brothers and sisters, that her parents, her mama, Big Mama, had about a 50-50 chance her child would make it to 5. Can we even wrap our heads around that? Can you wrap it? How many of you are parents? Raise your hands. Really? Oh my goodness, I usually have quite a few, but okay. Someday, some of you might become parents, and you can't even wrap your head around the idea. You won't be able to wrap your head around the idea when you hold that baby in your hands that there's a 50-50 chance that you'll see him at 5. But that's the way it was not very long ago. So we're incredibly lucky that we have all of that. Now, not everybody in the world has that, but in developed countries, we have really made a lot of progress. But here's what I'm here to tell you. There is nothing more devastating to a human body in prime condition at the prime time of their life. There's nothing as scary or more devastating than an infectious disease. There is no metabolic disorder that is going to keep having you well today but dead in somebody's ER tonight. But an infectious disease can. So shouldn't we want to know about those particular diseases and what they can do and how they progress and what risk, what chances there are of somebody getting exposed to them, getting the disease, and what would be the proper treatment for that disease? Absolutely, we want to know that, and anybody going into those frontline professions should be required to take this. So when I think about you guys, you know, I think I've talked to some of you AP people about this. You know, you probably consider yourself human, don't you, Casey? Most days. She considers herself human. But at best, we're about 10% human. At best. Because for every one human cell, and we have trillions of human cells, don't we? You have 10 microbes that live in an organ. 10 to 1. So at best, you're about 10% human. But what we know about cells, are cells the smallest things that we know that have properties of life? Are they? But what we know about cells is that cells don't do anything without this instruction manual, this administrative office, this molecule that dictates everything that goes on in the cell. It's called DNA. In our human DNA, in our trillions of cells, our DNA, our recipe book in all those cells is the same recipe book. That's us. That makes us us. That recipe book has never been written before, and it will never be written again. And we have about 25,000 plus genes, recipes. Now that might seem like a huge number to you of things that are happening in your human body and how complex you are. But the fact is, those 10 to 1 microbes, the diversity of them and how many different ones live in and on us, their genetics, their DNA, there's 100 times more genes than we have. So at best, we're 10% humans, but more realistically, we are about 1%. And by God, that balance better be where it needs to be. Those microorganisms that live in and on us we're living in their gardens. You know, we call them our gardens, but no, we're living in their gardens. And if those gardens of organisms, that balance is off, what would be the problem with that? What would be the problem with that? Would there be a problem with that? Can we exist as a healthy human being in a sterile environment?
No.
Absolutely not. Absolutely not. From the time the amniotic sac breaks that you're in as a fetus, and the vaginal flora, which should the predominant flora there should be lactobacillus. You might want to write down that lactobacillus. Y'all, I'm going to phonetically try to say them better than I do Southern names. Okay, so lactobacillus is the genus. This is a bacterium. Acidophilus is the species. That should be the normal predominant flora in vaginas. What does the fetus have to pass through? The birth canal, which is the vagina. Isn't that right? The fetus, and this is great because that bacteria, that fetus it gets on them, they swallow it, it resides in their intestines, and guess what it breaks down? Lactobacillus. It breaks down what?
Lactose.
Which is
Milk.
milk sugar. That's exactly right. So that helps that baby to start digesting the milk it's going to be taking in for nutrients. So that's just one example, right? But the microorganisms that we get introduced to in the vagina as we're moving through, they actually start to school our immune systems. Our immune human cells are taught by the microbes that are in and on our system. Did you have a question?
Yes. You said, what was the acronym?
Which one?
You said the genus was
Lactobacillus acidophilus is the species. So that's a genus and species of a bacterium. There are hundreds of different microbes. Do they need to be in the right populations balance? They do. They do. Right? You guys have all heard of infectious diseases that can be devastating. Y'all have heard of people having encephalitis, which is itis as a suffix. Tell me, itis as a suffix always means what? Inflammation. So encephalitis would be inflammation of the encephalon, which is the brain. So inflammation of the brain, right? That doesn't even sound good, does it? And y'all have heard of, pericarditis. That's going to be inflammation of the lining that surrounds the heart. Peri means surrounding. Carditis, the cardium, the heart, right? Cardiac, the heart. Pericarditis. That doesn't sound good either, does it? Okay, but wait a minute. What about diseases like autoimmune diseases, like multiple sclerosis? What about even some mental health disorders that we know about, like some psychosis that we know about? Do you all know that almost all of these are linked to a disturbance or imbalance of your normal garden floras? In this class, y'all come to this class, and sometimes I have students who tell me, God, I'm scared to touch a doorknob after this class, or I don't even want to, we won't even talk about those other things you do up close. But just, I can't, this just freaked me out. Please keep in mind this. It is just a handful. it is just a handful of microbes that are dangerous to us as humans. All the rest of them are required for us to be healthy. They're required for us to be healthy. I think what we're going to be finding out here very soon is that through our packaged foods that have all kinds of terrible chemicals for preservatives, right? Through packaged foods, through things that have been added to a lot of our foods, this has disturbed our normal flora so much that we know this is linked to the increased incidence of autoimmune diseases, mental health, some of the mental health disorders. Y'all have already heard in your, this is just discussion. You don't have to write this down. Y'all have probably already heard that things like, I don't like labels. You know that. I don't like labels. I don't like people taking things. But any like chemotherapeutics, unless it's absolutely, you can put your finger on why you're taking it. But anyway, y'all have heard that things like attention deficit disorder and hyperactivity disorder, and God forbid, ADHD, you know, you get the label of both of them, right? So you've heard of those things. So many of them have absolutely been shown to be because of exposure to chemicals in foods, dyes, preservatives. And so what does it do? Those things are changing the normal floras in your colon, in your gut, on your skin. And so what that does is changes your immune response to it and how your immune system does respond to it. And this is, so it's not just infectious diseases that we're going to be thinking about here. We're going to realize that the microorganisms that live in and on us are important. And, you know, we probably all need to be hiking and getting dirt under our fingernails and maybe even drinking from the stream. Do you know what I'm saying? Not really. You can get some little parasites from doing that. But, okay. It's about water again. But they do make us healthy. And we've almost gotten to what's called the hygiene theory of disease. Have y'all heard of the hygiene theory of infectious disease? Which means that you can live in a too clean environment. That as we are getting older, we need to be exposed to more microorganisms. I'm not talking about the little handful of the criminals, the bad guys, but I mean the good ones. Do you see what I'm saying? All right. Hygiene theory of disease that you can be too. You can actually be in too clean of an environment. No worries at my house if y'all want to come over and be exposed to some stuff. But anyway, so this is actually letting you know that we really do live in a microbial world and we're dependent on it. So what the question becomes, like, a microorganism is so tiny compared to our big human cells. You know, our big human cells are complex. They have all kinds of organelles in them that have special functions, right, that are carrying out pretty specialized types of functions. And microorganisms, and one of the reasons they're called that, is that you can't see them with the naked eye. And you're going to have to use a microscope to help you to be able to see them. And they are tiny. Just to put your head around this idea about how much tinier there are, and of course this is a very simplistic analogy, but most people have been at a baseball field, right? So you've been at a typical baseball field and you know what the outfit, if you had to run the bases, you would know what that would feel like. Or if you had to run the post, the outfield fence, and come on around, you know how big that is. So if a human cell, mathematicians did this, not me, but if a human cell was the size of the whole baseball field, infield, outfield, whole baseball field, most microorganisms would be about the size of the pitcher's plate. So they're tiny compared to our big, huge cells, aren't they? They're really tiny. And they don't have the organelles. Bacteria don't have the organelles inside of them that we have and all those specialized functions that are going on. And instead of having like 46 chromosomes, they have one little circular piece of chromosomes and sometimes some little extra pieces. But they're really very simple in their life structure and function. They are alive. They're cellular, these bacteria. But they're very, very simple compared to our complex cells. So the question becomes like, how can any of them be dangerous to us? We've got these like big giant cells that are carrying out all these processes, and how can any of them actually ever be dangerous to us? Well, I want you all to know that, and this is fairly recent how they discovered that they do this, but bacteria can talk to each other. And yes, they're single-celled organisms. They're single-celled organisms, but there is something called quorum sensing. Quorum means that you have enough. Y'all have heard that if you have a meeting, you need to have a quorum, which means that you have enough there that you can vote. Have y'all heard that word before, quorum? Okay, well, anyway, this is called quorum sensing. And this, I want to give you an example of what is going on here. So how many of you have ever, is this a personal question? How many of you have ever had strep throat? Oh, wait, wow, a lot. Nobody has to write their hand. Okay, so actually, sorry if you've ever had strep throat, but okay. So most of you know that, you didn't feel good at all, did you? Right? Your throat was really sore. You probably felt pretty lethargic. You were tired. You might have been nauseous. Your head probably hurt. I mean, it was kind of systemic. It wasn't even just pharyngitis, was it? Pharyngitis means inflammation of the throat, the pharynx. The pharynx is the throat. So pharyngitis is inflammation of the throat. And it wasn't even just your throat. You felt really not great. That's caused from a bacterium, and I had already told it to you, but here it is. So I'm giving you two today. This will be the second one. Streptococcus pyogenes. Streptococcus pyogenes causes strep throat. This is a tiny, tiny little bacteria. It's even smaller than the average bacteria. It's really tiny. And they're single-celled organisms. So how can they cause so much havoc in you? How can they do this? Well, what we figured out is this. What we have figured out is that when there's just a few of them, they are very quiet. They're not causing any trouble when there's just a few of them. They won't turn on what we call their virulence factors. I'll talk about that later. They won't turn those on though, because they want to stay under your immune system's radar. Because you have these white cells that are wicked. I'm serious. They're wickedly wonderful for you. They're like your SEAL teams, okay? They're like your Marines and your SEAL teams combined, these white blood cells. And they're just looking for somebody that is a bacterium that's going to step out of line and they're going to kill it, right? But what we find out happens is that these microorganisms, if there's just a few of them, like you just ate that potato salad and you got a few of the ones that can cause food poisoning, right? Potato salad should be refrigerated for that very reason. But you just got a few of them. But what will happen is they will stay really quiet until there's enough of them there. And then they will turn on their virulence factors. And they will start causing local and sometimes systemic damage. So how do they know how many are in the environment? How do they know when there's enough of them? I'm going to tell you how they know, and I'm going to give it to you by an example. Are y'all ready? Now, y'all don't have to write down these species. It's just the bacteria. I'm just showing you what quorum sensing means. We know this because of a bacterium that lives in this little squid's underbelly. This squid is a squid that's found in Hawaii, in the very shallow waters of Hawaii. And so y'all just listen to the story, not quite. So it lives in the shallow waters of Hawaii, and it feeds at night in these shallow waters. The squid does. And what it does is it has this bacterium that's in its underbelly that during the day, while it's sleeping in the sands, in the shallow sands, that bacterium is dividing. Because bacteria can divide every 10 to 15 minutes. So 1 becomes 2, 2 becomes 4, you get it. So it doesn't take long. And during the day, when the squid is sleeping, this little pouch under its underbelly starts to fill with these microorganisms. And when there's enough of them there, by nighttime, its underbelly lights up, sends out a light. So when that squid, it's not lit up until there's enough of them. And then all of them at the exact same time turn on their bioluminescence. They turn on a light at the same time. And people were wondering, like, how did that happen? What was happening? what we found out is that these bacteria, like all bacteria, they're putting out little molecules in the environment. And if there's any like them in the environment, any within the same species, they are catching those little microorganisms, those little molecules. And as soon as enough of their little receptors have caught, they think, I got a lot of friends here now. And they turn on whatever virulence factor they need or that they have. These little bacterium turn on a light. Now, why would they do that? And why does the squid put up with that? Because the squid, when it comes out, the light is beaming down on the surface floor of the ocean. The moon is beaming on top of it. There's a sensor on the top of it that detects how much moonlight there is. And the squid has a shutter to control the light underneath it so that it doesn't form a what? If it didn't have that light, what would the squid be making as it's looking for food on the floor? A shadow. But because it's controlling the light, this is nature's stealth bomb. When the sun comes up the next morning, that squid squeezes out all the microbes into the ocean. They get diluted and they turn off their lights. And it goes back to sleep in the sand, and the microbes fill up for the next night to turn on their lights. Is that pretty cool? Are y'all not thinking that's cool? Okay. So this is one of the reasons that we know, we study, microbiologists studied this and figured out like how these microorganisms are bioluminescent. Like they have the ability to turn on that bioluminescence, but why aren't they turning it on? And that what they found out is they only turn it on when there's enough of them present for it to matter. Do you get what I'm saying? The strep pyogenes that causes your strep throat does the same thing. If there's not enough of them in your throat, they're not going to alert your immune system cells that they're there because they would immediately be destroyed. They wait until there's enough of them there, and then they turn on virulence factors. And we're going to talk about what virulence means, like when they're doing bad to you, right? So they turn them on all at the same time. That's why you become overwhelmed and you end up getting sick from it. Does that make sense? So this is quorum sensing. It explains to us that these microorganisms, when there's just a few of them, and they're putting out these molecules, then that's okay. But when there's enough of them present, then they can change behavior. They can become criminal in their activity. Does that make sense? And this is how they talk to each other. What we also know is they can talk between species as well. They don't just talk to their own species. The microbes that make up your gardens, that are your normal flora, I'm calling normal flora gardens. If I see something y'all don't know because I'm just like used to talking about it this way, please stop me, okay? The microbes that make up your normal garden and your floras, they know what's present. They know who's there and what's there, who else is there. They're communicating between species and within their own species. And so why is this important? Did I think this is important just because I think it's cool that this is a stealth bomber? Why is this important? Can we see any application for knowing this, for understanding this? Do you see any application in this? Maybe not. Right now, when you have strep throat, what do you have to do to feel better? An antibiotic, which means that you're taking a chemical that is going to, when you talk to it, do you take it and say, you take that pill and you say, okay, just treat my Streptococcus pyogenes, but leave all my normal flora alone. Don't fool with anything else. And it listens to you when you take that pill, or when you take the antibiotic, what does it do? Well, it doesn't kill everything, but it kills a whole lot more than just your strep pyogenes. It kills a lot of your friends. And it kills a whole many more than your friends than you would want it to. Isn't that right? And right now, is there anything that we're worried about with the overuse and the misuse of antibiotics? Not that it's an antibiotic, I'm just holding it up. What'd you say? What is a super bug, Brittany? Has everybody in this room heard that there are now some bacteria that we don't have anything that we can really treat them with well, that treats them. There are actually some bacteria now that we have nothing to treat them with. But we have others that we have things we can treat them with, but by God, it's like using a cannon on a housefly. I mean, that's what we're having to do. Would you use a cannon in your kitchen for a housefly? When you have used the cannon in your kitchen for the housefly, what happened to your kitchen? You destroyed it. And that's what some of these drugs we're having to give for these superbugs are doing. They're doing a lot of collateral damage. So y'all have all heard that by the misuse and the overuse of antibiotics, we are now getting what are called super bugs. Y'all have heard those, right? Let me give you an example of one. And y'all would need to add this to your list. This is number 3 to your list, okay? This is just one. Is everybody good so far? Nobody's quitting yet, are they? Is everybody still handing in the contract? All right, so, okay. Look, people aren't, they're not even looking up. Does that mean something? All right, here's one. It's MRSA. MRSA. Capital M, capital R, capital S, capital A. People call that MRSA. Okay, they just MRSA. They call that. All right, but it's really capital M, capital R, capital S, capital A. And I want you all to know exactly what those letters stand for. Those letters stand for, and I need you to know by Wednesday, those letters stand for methicillin-resistant Staphylococcus aureus. Methicillin-resistant, and then the name of the bacteria, the genus name is Staphylococcus. The species name is aureus. Y'all, after this class, when you can use electronic devices, y'all can Google that. Okay? And
The species again?
the species is aureus. A-U-R-E-U-S. And see, I never spelled it like that. Because he's been so nice to
Microbe and organism, are they the same?
Yes.
Microbe and bacteria are the same.
Yeah, it's thank you. And I need you all asking those kinds of questions because I'll say bugs or I'll say microbes or I'll say microorganism. Yes, and I'm usually referring to this, yeah, just little things. Okay. Okay. Now, MRSA is one that y'all have all heard of. But that's the least of our worries out there right now. That's been around for a really long time. And when y'all hear that someone had a staph infection, a lot of people in the community feel like that's something that an infection somebody got from the staff of workers that work there. Do y'all know that that is not right? That's not true, right? It is actually from a microorganism, a bacterium called Staphylococcus. Staphylococcus, the genus Staphylococcus. And it is usually always Staphylococcus aureus is the species. There are many other species of Staphylococcus, but Staphylococcus aureus is the one we mostly worry about. Now, it's usually not so hard to treat. It really isn't. I know y'all have heard differently, but I've worked in ID for many years, and I know this. So Staphylococcus aureus is on everybody's skin as part of their normal flora. It's in all of your noses. It's in crevices that we won't bring to attention right now. But we all have Staphylococcus species in and on us. We all do. And of the Staphylococcus aureus, quite a few of us, probably most of us, have, as one of our subspecies of aureus, we have MRSA. You will hear the MRSA classified as hospital-acquired, which means you got it from where? Or community-acquired, which means you probably got it from where? But guess what? Anybody who works in ID, we don't care in infectious disease because most of us have it. Most of us have it. It's part of our normal flora. But guess what's keeping it from causing us any trouble? All of our other what?
All the other flora.
All the other flora is keeping it down. Most of the infections, not all, but most of the infections that people die with are actually infections that were part of their own normal flora, but it got out of balance, so it took the opportunity to cause disease in them. If you've ever known anybody who had MRSA, and I just had this conversation with somebody in my family. I didn't have a conversation because I didn't try. Well, I wasn't going to try. Because that surgeon, everybody in the hospital that time had that. Guys, let me just say this. Staphylococcus aureus is on our skins. It's part of our normal flora, and it usually causes no trouble as long as we are healthy. Now, if we become not healthy, if we become ill with maybe influenza, which just wiped us out, our immune system's being challenged and we're not feeling well, or we have surgery, or we have a hip replacement, or we have something that is insulting to us, then guess what's going to be the first thing that causes a problem? What was on your own skin, right? And this is why those diseases are called opportunistic diseases. I would want you all to be able to explain to me that an opportunistic infection is an infection that was caused from one of your own microbes. That was just took the opportunity to cause disease because it had the opportunity. Do you get what I'm saying? Guys, have y'all ever heard of boils? Maybe you've seen a boil or had a boil, or they're not very uncommon. Have you heard of styes on the eyelids? Have you? Styes and boils are caused from Staphylococcus aureus. Where did that Staphylococcus aureus come from? That person's own skin. It's nothing to be afraid of. It did. It did. It came from their own skin. Here's the thing. Keep your immune system strong. Keep your normal flora balanced, right? Keep all of that, and opportunistic diseases won't happen. How many of you all have heard, I am getting off topic a little bit, but does everybody follow me okay so far? I mean, you don't have that many notes, have you? How many of y'all have heard of yeast infections? A yeast infection? Have you heard of a yeast infection? When do people get yeast infections? All right, look. So has anybody not heard of a yeast infection? All right, look. So on our, don't write this down yet. You're gonna get to it in a second. On our skin, I didn't mean to introduce so many microbes names today, but on our skin, in cavities that we have, not everywhere is colonized. When I say colonized, means that there's microbes there. So we do have some sterile sites, but most places that are colonized and have organisms, we have bacteria, yeast, protozoa. We have these things that live in and on us, hopefully in harmony as beautiful gardens, right? But what happens is if you take an antibiotic, what do antibiotics work against? Only bacteria. That's right. Nothing else. So you just took that antibiotic and it didn't listen to you when you said, don't do anything to my vaginal flora, okay? Just treat my strep throat or just treat my tooth abscess, but leave all my other areas alone. Does it listen to you? So it wipes out the bacteria. Now the yeast that are part of your normal flora take the opportunity to cause disease. So when a lot of women have a vaginosis from yeast, it's called a yeast infection. They call it a yeast infection. And it almost always follows doing something like a course of antibiotics. Or, God forbid they ever do. Women should never douche. I think everybody knows that. Women should never do that because guess what that does to their normal flora? It messes it up terribly. That is a horrible thing for women to do. So you do not do that. But anyway, so that's yeast. Let me tell you what the name of that yeast is. That yeast is called Candida. It starts with a C. C-A-N, Candida, D's, Candida. And the species name is albicans, A-L-B-I-C-A-N-S, albicans. That's a yeast. That's a yeast. And it belongs to the fungi family. So do antibiotics work against it? No, you have to take an anti-what? Fungal, right? How many of you have ever seen somebody who's gotten tan, they get really tan, and then all of a sudden you'll start seeing these lighter patches on their skins? Has anybody ever seen that happen to people? Tan, if you haven't, you can Google this after. Y'all can Google some. The only thing bad about Googling these diseases and getting images is that you see the worst scenario, and then you think it has to look like that, and that's crazy, you know. So that's, let me warn you about that. But anyway, what does the sun do to our skin? Is it healthy for our skin? No, it's really damaging to our skin, and so our melanocytes are having to put out melanin to try to protect you from the UVA and B rays, and you know that can change the DNA, and so it's really damaging. So what happens? It damages some of that protective microorganisms that live on your skin, and it's damaging them. But guess what's happy? Guess what those little white spots? Guess what those little things are? Those are yeast infections. That's Malassezia furfur. That's a fungus. So what are they going to give you to treat that? An antifungal. Yes.
When somebody gets sick, I call it all like antibiotics and one for bacteria and stuff.
Okay. So we won't add that one to our list yet, because I feel like y'all all run screaming if I give you too many names of organisms and what that. Clostridium difficile is nicknamed C. diff. How many of you heard of C. diff infection? A lot of you. Good. Okay. So I mean, not good, but I mean, I guess it's bad. But okay, so Clostridium difficile, most of us have this. I mean, we can have this. But what happens is in our colons, and we get it gets introduced to us, and it's fine as long as we have all of the other normal flora there suppressing it. But if you take antibiotics, what are you doing to the microbes that live in your colon? You're messing up the balance. And so now that person, the C. diff, starts growing at such a rate that they start producing, turning on, sort of like not a light in this case, but toxins that end up causing what is actually, you guys have heard of it as antibiotic-associated enterocolitis. But I will probably also later give it to you and tell you that, and that's really true, enterocolitis. Colitis means inflammation of the colon, right? But it causes a pseudomembranous enterocolitis. It's horrible. It's a horrible infection for the person who has it. And I don't mean horrible because, you know, it has an awful, y'all know the smell is diagnostic, isn't it? The smell is diagnostic of C. diff. It's just on another level, right? But it's not that. It's that this is painful. The people are incredible, have abdominal pain. They can become incontinent. They're not getting the nutrients that they need. This is a horrible thing to try to deal with, and it can be really hard to get rid of. So we're going to talk more about that later. But yes, that's because of the overuse and misuse. When I say overuse, what do I mean? Of antibiotics. And y'all want to know that. What does overuse of antibiotics mean? Using them when you don't even know if there's a real bacterial infection. Do y'all know how many parents I know who go in and say, my child has an ear infection, and if I don't get an antibiotic, I just don't know what. I'm not leaving there without an antibiotic. Have you heard that? How many of you heard that? It's wrong, because most ear infections are not caused from bacteria. So you're setting that child up for overusing antibiotics, which is destroying or hurting their normal flora. The studies that are going on now about kids that have been on 3 courses of antibiotics in the first 2 years of their life and how it's affecting them a decade later are frightening. And most of them are from overuse. It does not need to be prescribed. And when they're needed, they're really needed. And they save lives. But not for a lot of things they're being used for. What is misuse? You might think misuse is also that overusing, but overuse means they're being overprescribed. They're being prescribed for things that you don't know if it was bacterial. It was probably not. It was probably viral. And do antibodies help you against viruses? No, they don't. They actually hurt you. Because if you have a virus, your body knows it's a virus more than than a bacteria. So your body's immune system's trying to fight the virus. But guess what an antibiotic does to your immune system? Suppresses it. So you're actually hurting them in another way by giving an antibiotic if it wasn't needed. Are you good with that? What does the misuse mean?
Like they don't take it as long as it's supposed to.
Thank you. How'd you know that? And this is what they say, like I'm the grandma. Casey would come to me and say, you know, and I'd hear her sniffling, right? I said, come on, sugar, I got a little bit of amoxicillin I have left over from my last name's right here in my cabinet. I'm going to give it to you. You need this. It's going to make you feel better. How many of you have grandmamas like that? Grandmamas love you, but they should not be prescribing antibiotics, and they shouldn't have any that are left over. And you shouldn't stop taking them unless you've gotten permission to stop taking them. Because let me tell you what happens. If all of you all were Streptococcus pyogenes, each of you are a little single set, because they are, bacteria are single cell, these are single cell organisms. Y'all are all Streptococcus pyogenes. You've all turned on virulence factors. You're making this person feel like hell, okay? So you guys are all just really bad guys. But you're not all exactly alike, even though you are all called that. And I take an antibiotic, and I'm going to wipe out everyone that's weak in here. And guess who's left behind? The ones that are a little bit stronger. And if I don't take the antibiotic as prescribed, that means on the hour it was prescribed, and for as long as it was prescribed, the few that were the strongest are the ones that are behind. Yes, they haven't turned on their light. They're not turning on their light. But by God, when there's enough of them, guess what they're going to do? Turn on that light. They're going to turn on that virulence factor, and now the next time you have to treat them, is that same drug going to work necessarily? Not necessarily. And if you do that enough times, eventually it won't work at all. Do you hear what I'm saying? So taking medicines for the prescribed period of time wipes out even the stronger ones of the species that are left, taking it for the prescribed time. The reason that they don't give a lot of antibiotics now that need to be taken every 6 hours is because people just aren't disciplined enough to take them every 6 hours. And usually you have to wake up, during one of those periods of time, right? So that's why they do that. They also have medications now. Oh God, that reminded me of something when I didn't answer the question. Y'all have to keep up with me. All right, so anyway, they give medicines now that stay in your system for 10 days. They'll give you that because they know you're probably not going to take it on the right time or for long enough. Do you get what I mean? But that is the misuse. And that's the misuse, too, when somebody offers you theirs. How many of you have been offered antibiotics that somebody had? I'm telling you, look at that. That is the scariest thing. Can I take a picture? Because that's awful. That's horrible. You didn't take them, right? Don't tell me. I don't want to know. But hopefully you didn't, right? So what I was going to tell you about the quorum sensing, why can you see the application that this is important? Is because we have these antibiotics now that we are we're almost at the end of our antibiotic use in medicine. It's been a nice run. Since World War II, the end of World War II, I wish it had been the beginning, but the end of World War II, for personal reasons, I wish that. But all the way through to now, it's been a nice run, but we're almost at the end because the microbes it's more than MRSA out there. There's vancomycin-resistant enterococcus. That's much scarier. I'll talk about other ones. But there are way more super bugs than MRSA. Everybody, almost, I would dare say that 3/4 of us have MRSA in our noses. That's not even a scary one. It isn't. I'm just telling you. It isn't. But the reason it's important is because if we could somehow change how they communicate with each other, would they turn on their lights? Would they be able to turn on their virulence factors if they didn't know there was enough of them in the room to do it? Do you get what I'm saying? So understanding this quorum sensing and these receptors that have to be present at just the right way, if we could block those receptors so this little guy doesn't know to turn on its virulence factors, This is the newest, this is what's going on right now in research, and this is going to be the next generation of antimicrobials as far as bacteria are concerned, is going to be dealing with quorum sensing. That's why I wanted you guys to hear about it. So, do you have any questions for me yet? Is everybody good? Yes.
Could you define virulence factors?
Yeah. Okay. So I had said I'm going to bring it up later. It's really hard because I get in here and I just want to tell everybody everything at once, right? We do get to this later, so we get to things, and then I start repeating myself, which that's not a bad thing, I guess. In a classroom, it's not a bad thing. So, virulence factors. Let me give you one other thing before I give you that. I just told you that most microbes are your friends, didn't I? Did I say that? Most of them are your friends. They can never cause you. They can't even they couldn't cause you disease if they tried, right? So most are your friends. But in this class, we concentrate on the bad guys, right? So I want you to know that the term pathogenic means that the microorganism has the ability to cause disease. That's what pathogenic means. If something is a pathogen or pathogenic, it means it has the ability to cause disease. Does Staphylococcus aureus always cause disease? No, but can it be a pathogen? It can be a pathogen. It can become pathogenic. It can take the opportunity to cause disease. Now I want to answer your question about virulence factors. Now, before I answer it, my kid said something. I want you to just listen to this, and then I'm going to word it differently, okay? So y'all have now heard about Staphylococcus aureus. You've heard about Streptococcus pyogenes. We didn't write it down, but you heard about Clostridium difficile, right? These are different microbes, aren't they? Different bacteria. Yeah, they are. So they're different bacteria. They don't all have the same virulence factors. They have different ones, right? So when you hear about a microorganism, some of them are much more deadly than others. What makes them more deadly is that they have more serious virulence factors. They're more virulent. So a virulence factor, for example, a factor is typically a protein that they can produce that causes devastation. A virulence means it's going to cause harm. So some of them can lyse your red blood cells. Does that sound like that would be a good thing? No. Some of them can produce a protein that causes them to hide from your immune system. Does that sound like that would be good for you? Some of them can produce structure proteins, if you will. I'm just going to lump them into proteins because the factors are proteins. Some of them can produce proteins that are called capsules that make them stick to your cells. So that helps them to adhere and invade into your cells. That would be another virulence factor, right? So a virulence factor is just a product that they can produce that can cause you harm. Some of them have outrageous ones. Some of them have not such serious ones. Did that answer your question? No?
Yeah, are bacteria the only ones that have virulence factors?
No. So no. There's other microbes too, but I'm just talking about bacteria right now. Okay. Yeah.
Can you give us a definition for the keyword?
Quorum. Quorum is quorum. To have a quorum means you're voting. You're voting, if you will. So if you were looking and there's just one little one out there, or just very few, there's not a lot that can happen. But if you have the majority, okay, I'll talk about politics. But if you have the majority, you can start doing things, right? So you have a quorum. And if you have a quorum that's sensed here, then they'll start producing. This little microbe, let's just say this little microorganism, and this is another little picture of it, or we could use this picture. They all have the ability, let's say this is E. coli, they would have the ability to lyse your red blood cells. They would have that ability. But are they showing it? Are they producing that toxin yet? No, they're not producing that yet. But if enough of them get present, can they turn it on? And as soon as they sense that they had a quorum, they had enough to vote it, they'll turn it on. That's all that means. You can look at other, ways that that's sensed, but it just really means that they're sensing that there's enough of them there to be able to make something happen. Right? All right. I know y'all get frustrated because I never end up saying the same definition exactly the same twice, but okay. Microbiology, when you think about just the definition of microbiology, it really is the study of these life forms that you need a microscope to see. That's all that really means, microbiology. And under that, when we think about these organisms that are sometimes so small that we need a microscope to see, we have very different categories or groups of them. So there can be the bacteria, which is a kingdom. Y'all remember, how many kingdoms did you learn in your basic biology classes? I learned about 6 kingdoms, and you learned 5, but they created another one since I was there. So anyway, but no, okay, so there's kingdoms. There are these kingdoms. Bacteria are going to be the bacterial pathogens that we look at mostly fall into this category. This archaea, this is actually sometimes written in your textbooks as archaeobacteria, one word, archaeobacteria or archaea. These are ancient bacterial life forms. This category, and I'm going to tell you right now, that's all I really want you to know about this category, is that these are microorganisms that are so ancient. We do think that the life that we see today, even the complex life that we see today, originated from the precursors came from this category. Today, where we're seeing archaeobacteria, we don't see pathogens, human pathogens in this group. We don't really, so I'm not going to really even talk to you more about this, except that just that you know that this is a kingdom. It's also a domain. But anyway, we find these in places that we didn't think life could even exist, like in the Dead Sea, where it is got so much salt that we thought that life couldn't exist here. But guess what we find? We find some bacteria that are living there. And the volcanic vents under the ocean that are like, 1,800 degrees Fahrenheit, so friggin' hot. There's some life forms there. The bacteria that are there that have figured out how to live in these very hostile environments on this planet, they're there. And they're still there. And you know what? When something might take all of us little warm and fuzzy creatures out, all of us little cuddly creatures out, guess what's still probably going to be here? Well, that's depressing. So we're moving on along now. Okay, but anyway, there's also a kingdom called protozoa. These are also single-celled. These are single-celled organisms. They are much more complex than bacteria. But protozoa is a kingdom all its own. And do you want me to give you an example of a protozoa that you guys might have heard of? Okay, I'm going to give you an example of a protozoa. I'm not going to give you that one because you'll feel like I'm just, all right, I'm going to give you the genus. Now this is a genus and it's a protozoa. Would you have to know it's a protozoa? Yeah, so it belongs to that kingdom. Single cell, huge though compared to little tiny bacteria. Here it is. It's called it starts with a P, Plasmodium. Plasmodium. I am saying it like that because it's spelled exactly like I'm saying it. Plasmodium. Plasmodium. See, I really hate standing up here spelling, but okay, that's the genus. There are several species. But for right now, just say Plasmodium species. You don't have to write them down, but later we're going to look at them. Vivax, Falciparum, Ovale, and one called Malariae. What disease do you think this protozoa causes? Malaria. Do you all know that more than 1 million children die annually? Can you picture 1 million children? I can't, because it would hurt my mind. Annually from malaria on this earth. And it's from that protozoa, Plasmodium. It's a serious consideration, isn't it? Plasmodium. Fungi. Did I give you one example today?
Yes.
What was it?
Candida albicans.
Exactly. Candida albicans is in this fungi category. It's a yeast. In the fungi category, we have yeast and molds, and this is just one example. And to diagnose these, we really do need to have a microscope to be able to see these. Now, there's some molds that are big enough that we can actually see some of the mold products, but when we're talking about the disease that they cause, we would need a microscope. This is a kingdom. Now, helminths belong to the animal kingdom. Y'all have all heard of the animal kingdom, haven't you? And helminths are what you all call worms. Okay, can worms be unpleasant? We probably all had worms. If you haven't lived. You haven't probably been in enough environments. Most of them are self-limiting. So most of the things that we talk about and we encounter are, even if they do cause disease, they would be self-limiting kinds of diseases. Not all of them, but some of them. So anyway, but helminths, so roundworms, tapeworms, flukes. Y'all have heard of these, haven't you? Okay. Now, viruses are not alive. They're not alive. They're not in any of the biological kingdoms or the 3 microbiological domains. They're not. Viruses are not considered alive. What did I tell you is the smallest thing that has life? A cell. And bacteria are single-celled. Archaea bacteria are single-celled. Protozoa are single-celled. Okay, so you know that these are cells, and some of these are multi-celled, right? But viruses aren't cellular. They're not cellular. Viruses are considered to be either active. So cells are considered alive or dead. They have life properties or they don't. They're dead, right? But viruses are considered to be active or inactive. And viruses do not have the cellular machinery they need to divide. They cannot divide. They cannot extract what they need from their environment for energy. They cannot do any of those things. They're not considered alive. But does that mean they're not worth studying? Because actually they can do a ton of damage, can't they? And some viruses are incredibly deadly. What's a virus that you all know about that there's an outbreak right now going on in Central Africa, but I don't think they have it contained quite yet? Ebola. Have you heard of Ebola? That's a virus that has about a 90% untreated. It has a 90% mortality rate. That means 9 out of 10 die. And it doesn't matter that you're the young or the old. You can be in prime, and you're still in that 90+%. That's a deadly virus, isn't it? So, but most viruses are very much not to worry about like that. You know, they're going to cause maybe a lot of times there's some childhood viruses that kids don't stop skipping and jumping, do they? And that's just a normal part of that. But some can be deadly. But they're not considered alive. They're considered parasites. So what's a parasite? What is a parasite? They're actually considered obligate parasites. Obligate parasites means they must be parasitic. It's not just because they want to live off of something like today, but they don't need to. They need to live off of something, another host cell. That's what obligate parasite means. It has to have a living host cell to divide and replicate itself. Right? Is that right? And I don't care much about biology. So, I do, and I'll bring it up later. But anyway, so what I'd like you to know is this, and this chart I don't love either, but okay, I'm going to tell you. In microbiology, we look at life forms as 3 domains, and I want you to know there's 3 domains, if you will. I want you to know there's 3 domains. The 3 microbiological domains are bacteria, archaea, and you can put archaea bacteria if you want to. So bacteria, archaeobacteria, and eukaryotes. Eukaryotes. Can y'all see that from where you're standing? I mean, from where you're sitting? Eukaryotes. Okay, then peek at it, everybody can. Okay, so eukaryotes. EU as a prefix always means what? True. It always means true. EU always means true as a prefix. So karyon means nucleus. So this, everything in this group is going to have a what? A true nucleus. That's exactly right. These two, archaea and bacteria, they're prokaryotic. They're prokaryotes. And prokaryotes means that's before nucleus. They don't have nucleuses. They don't have any organelles, actually. They're very simple single life forms. But eukaryotes have true nucleuses. So the three domains, tell them to me again. What are they? Okay, great. Under those three domains, there are 6 kingdoms of life. The first is bacteria. You will also, depending on where the textbook is written, sometimes see that as eubacteria, true bacteria. Archaeobacteria, that's a kingdom. So there's your 2 kingdoms. Is that right? And then under the eukaryotic group of domain, there are 4 kingdoms. Here are the 4 kingdoms. Are you ready? The 4 kingdoms are, it's a weird picture. The 4 kingdoms are protozoa, proteus, right, proteus, fungi, plant, and animals. Are we good? Scientists love to classify things. Do you think they classify them just to spend time in the day? No, they classify them by like characteristics, and they understand, evolutionary relatedness because of that, and all kinds of reasons for doing this. But there's rhyme and reason for these classifications. So the 3 domains, you know them, right? And do you know the 6 kingdoms? Do you know the 6 kingdoms? Yes. Okay, great. Okay, so I actually have PowerPoints that go along with this if anybody's interested in that. And of course, I'm not making any of this stuff up. So this is like all in here. Now look, guys, I do want to talk to you about something that was in the paper. I think it was yesterday. I forgot. I think it was yesterday. Richmond Times paper. The Richmond Times paper yesterday. It was an article about a woman from Charlottesville who died from rabies last year. And so she died from rabies. Rabies is a disease, and y'all want to write this down. Rabies is a disease, and I have the article in my purse, but of course my purse I didn't bring with me in here. Rabies is a disease that is infectious, right? So what does that mean?
It can be passed on.
You can transfer it to somebody. Rabies is a disease that's caused from a virus. It's a virus that causes this, and it's a virus that attacks the central nervous system. The central nervous system is composed of the spinal cord and the brain. Does that sound like something we want to have an infection with? No, right? So rabies is essentially 100% fatal. Now I know a couple of you are out there and you know that there have been a couple rare incidences where a person with rabies who had contracted rabies would survive. But it is still, in any ID department in any university setting in the world, would be considered really 100% fatal. Now, this woman in Charlottesville last year had traveled to India. And I think it was talking about in her travel, she went to this yoga thing, and I don't know. She was traveling to India, and she had an encounter with a doll there, and it bit her on the hand. And then she got back to here, I guess Virginia, somewhere in a Virginia hospital. She's from Charlottesville, so probably the University of Virginia. And she started with symptoms of chest pain, arm pain, chest pain. She's in her 60s though, so you're thinking maybe you ruled out heart attack, aren't you? So anyway, it took a while, because are you seeing this woman and thinking rabies? No, So it took a little while. It took about a couple of weeks. She was progressively getting worse, and she ended up dying. But the people the health professionals that had worked with her, I think it was something like I want to say 273 for some reason, $1,000 worth of treatment for them, because they had to get immunized. They also ended up getting immunoglobulin. If you get exposed to rabies, it's 100% fatal. So they're not just going to give you a vaccine. They're also going to give you already prepared immunoglobulin shots. So everybody had to go through that. Now, of course, I'm not concerned so much about the cost. That's not why I'm telling you this. I'm telling you this because, that's just another reason for people in the health profession. You're on the front lines. You need to understand when people come in. You know that whole universal precaution thing? What that really means is you treat everybody like they've got what? Everything, including rabies. You do. And if you do that, then you're just going to be fine. I don't think people need to be afraid. They certainly don't. But they certainly also need to be smart in the health profession. So anyway, I do have that little thing if anybody wants to see it. All right, now look, I've gone a little bit over, and I think there might be a class scheduled for in here. But I don't have a lab today, all right? But usually our lab will be in room 28, which is on the other corner of the building here, by the bookstore. Y'all have any questions for me? I need my contracts. I hope everybody's going to stay in class. I need the contracts. And do you have any questions for me? So do we have enough things that we can actually do are you contract? All right. So do we have enough, y'all have enough notes that we can come up with 10 questions? Okay. Thank you guys. We do have that. Yes. Yes.